We'll give you an overview of data communication networks. Always remember this, all people seems to need data processing. So what is a network? Network is basically a connection between group of people, devices, objects, sharing meaningful information with one another. A very good example is a family network, right? Um, as father, mother, child, children are humans. They basically pass information to one another, and we can identify as one person as one node passing to another node, which is another human, right? Also, we can also have a peer network where you would have, let's say, your family is one node or a peer that can connect to the school, and the family is also connected to work. The family is also connected to store and the restaurant, right? And then we can also use these restaurant network analogy. For example, you go to a restaurant, right? The customer interacts with the restaurant server, and the restaurant server will then grab the specific items that the customer wants, right? Or order that to the kitchen. And client is definitely the customer side where they interact, right? With the restaurant server, and the server is again would be the one checking at the back end, which we can call server in computers. Contact network could also be associated with a different type of network, right? To get the perfect job, you need to have a bunch of things. You need to have a friends, which is your networking or connection, a former employer, a teacher, friend, work associate. Those are the things that would help you get the perfect job. And as we mentioned before, devices also communicate via networks. As you can see, some communicate via wires, right? You would see two computers talking with one another using a wire, and also to the printer, and also it can talk to another device using a wireless local area network, right, with the Wi-Fi. And why do we need to have networks? Again, it's to share information, right? So let's say you have two computers, a very old style computer without any wireless capabilities. How can they share information to one another? And again, this is through a networking cable, right? Or else the other computer might not know what's happening. This is very important in business where, let's say you have a worker is currently doing something, right? And he, let's say, saves a lot of transaction data, but the other computers in the company doesn't know about what's happening with those transaction data. So that isolation and that information not being shared would be very inefficient, because what would happen now is the other coworker would then go to that person who's updating the transaction data to check what's the latest data, right? And can you pass it over to me? And that is one of the things that networking is trying to solve. And also for referrals, right? To connect to for referrals, we need the network. You have the mice, speakers, it's connected to a cable, others using Bluetooth, others using Wi Fi. And why do we need? Again, save information, share information. So, storage, right? Applications, and collaboration. Again, data communication networks is a transfer of data between 2 points. There's a source and a destination, right? Think of the source as a human talking to another human, and that other human is now the receiver, right? And basically, the receiver, when he hear about what you're saying, he would try to decode and understand the language, right? In network, it's similar, right? So let's say a computer would talk to another device, right? It would basically encode that, right? Maybe change that format in a machine language, right? And then now it would be transmitted, shows with the TX, and goes to a channel. Again, that channel is the one connecting to the source and receiver, right? And then the RX, the receiver performs, try to pass it over to the source decoder to make sure that it's now understandable with the other end of the network, let's say the device, right? Or human. Again, if you want to make this an overview more simpler, we have the source and the receiver. And it could go vice versa, right? I mean, it's bidirectional. Complex network structure, most of the time, this is what we see. Everything goes to the cloud, meaning to the internet, and we don't really know what's happening. We just know that it would send it to the source, to the receiver, right? And the receiver would send back something. So we do have different data communication networks. We have transmission method, data flow direction, network topology, geographical coverage, right? We do have asynchronous transmission, and we have synchronous transmission. Synchronous, when we say synchronous, it goes step by step, right? And let's say it does the first step, it does the second step, and it has a large amount of data to process. It would first try to finish that second step before it can move on to the third step. When we say asynchronous, it doesn't matter if the second step is a large data to be processed, it will still move on to another step while it's processing the second step. So think of it that way. And transmission method, with this diagram, you would see, right? The first one at the top is the asynchronous, right? It doesn't matter, it can send characters by characters, while the synchronous, it would complete all the characters before it's sent, right? We'll move along. One directional and bidirectional. Remember this phrase? Network topology, and we have a different type of network topology. And as you can see, we have three: bus, ring, star, and mesh. This is point to point. This is point to multipoint. This is multi-drop topology, right? This is a bus topology. And just read on with the advantages and disadvantages in the slide, right? And I know there's like a lot of different topologies here, but as you try to read the definitions here, you would eventually understand that not all of these topologies are being used, right? But they have been used before. And again, through learning some of the older topologies, it will make sense why we would stick to our topologies that we currently use, right? Mesh topology is something that is really being used. Um, let's say you even have like a product that has a Bluetooth mesh topology as well, like your devices. Let's say you have different Google devices as well, right? Also, going back, let's say you have routers and Wi-Fi, right? Some of them implements mesh topology where instead of like a router extending it, it's basically a new, think of it's like a new Wi-Fi emitter, right, or receiver. For geographical coverage, we have the personal, local, metropolitan, wide area networks. We are used to using a lot of the LAN, or we're more aware of this. For the personal access network, it's very close range. If you remember this, it's the infrared days. If you want to play two-player with Snake, Game Boy Color, you need link cable. AirPods using Bluetooth. And this one is through, it's kind of dark, but it's using two, I think this is PSP, where people can, gamers can play with one another. And you all know the modem and the Ethernet cable. And also, if you happen to be in this generation where people still flock to computer shops, they're using LANs, local area networks. Okay, transmission medium, there will be guided wireless, switching and broadcasting for data transfer techniques, called setup phase, data transfer phase, called teardown phase. We have packet switching, broadcast network access, centralized polling, and frequency division multiplexing, time division multiplexing. These are a lot of the things that we read, and just so you need to understand. And I know when you check the textbook, everything is a bit more technical. If you're going to a networking path, that surely will be very helpful. And you have more questions on that, feel free to ping me. But if you need a very good takeaway, learn the OSI model. All people seems to need data processing, APST and DP. Okay. Okay. So this analogy is self-explanatory. Let's move along. And in the OSI model, this is where usually the browser, when you hit the browser, it uses HTTP and HTTPS protocol. That's one of the protocols being used to communicate between applications, right? You can also have file transfer protocol, like for example WordPress sites and other web hosting. It's basically a file system hosted somewhere, and you need to do FTP to communicate. You also have POP3, which is for email communications. Also SMTP. Telnet is for virtual terminals, right? So we've been using them. It's just being abstracted from us, right? So every time we interact with the web, most likely, right, we're using one of these. The presentation layer has three things to do for the takeaway. It basically translates it to a machine readable, which is binary numbers, and it also does data compression to make sure that the file size becomes smaller and easier to transfer. And there's lossy and lossless. And lossless, like for example, when you bought a CD before, and let's say there's 16 songs, but let's say it's around 400 megabytes. That's very big, right? But usually when you get MP3 files in the internet, they're compressed, and they're less of a quality, but they're lighter weight. Maybe one song 4 MB, right? Instead of one song maybe 32 MB, right? So another way to know the quality of the songs or the data in the songs is if it's 128 kilobytes, it's basically a low level quality. If you start playing that in a big room or a high quality headphones, you would hear that you're losing a lot of audio quality. Usually you would go for the 300 kbps, something like that, right? And lastly, it does encrypt it to make sure that no one can just access the data being transferred. And then we have the session layer. Session layer is basically the one making sure the bridge is established, right? And a way to establish that as well is you have the authentication and authorization first to check if that person trying to access is really the correct person, right? And does he have the correct level of access, right? Once those are good, they can now establish a session, right? And as you can see this line from the laptop to the server, if you're authenticated and you're authorized, you can now have a session with the server and retrieve files. Transport layer, you have the following: segmentation, flow control, error control. Segments, right? You can have, let's say, different one in different applications. Or the other type of segment is you have different ones and go into one, right? Flow control is a topic where, let's say, your phone can only um, get 10 megabytes per second, right? Um, and then the computer has a transfer of 100 megabytes. What would happen there is the phone can only receive 10 megabytes per second, so it's limited by the receiving, right? Automatic repeat request. Again, data, whenever it's transferred, it's being broken down into bits or packets, right, or frame. Um, and then usually the receiver would know how many more of the unit from that broken down data is missing, and if it's missing, it will basically ask the sender, right, of that data, and resend that missing unit of data, right? So in transport layer, we do have TCP UDP. Yep, we've been using this in our everyday lives. UDP requires no feedback. Let's say someone is calling you or someone is doing video, right? It doesn't matter if the other person receives all the content or not. This is especially true, for example, oh, someone called you and you can't hear them because it's choppy or laggy, right? Because of connection. It doesn't matter. It's still gonna send, and it doesn't need to wait for the other person or receiver to say, okay, you have to have good quality of all what you said before you send it to me. No, it's just sends it right away. To make it more clear, when we say TCP, it requires feedback. For example, if you're sending email or text messages, it requires the sender to complete the message before it's being sent, right? And you always receive all the message or nothing at all. It's not halfway. Again, unlike UDP, it doesn't care if the audio is complete or not. It's just gonna try to send it, right? However, with our technology nowadays, with, let's say, YouTube or video streaming site, it's a combination of both because, again, they're checking if the receiver is receiving that, right? And again, with the advancement in technology, it, depending on your internet speed, it can reduce your visual quality as long as it still gives you a clear picture and a clear audio. Okay, the network layer, we always hear about IP address, right? And there's two logical addressing, right? It's IPv4 and IPv6. It's just version 4 and version 6. A quick takeaway is IPv4 is basically the ones that you're seeing, let's say the 192.168.1.1, right? Um, and IPv6 is a little like that. Again, main difference is that IPv4 has less of numbers of IP address, and IPv6 has more, right? And it helps, again, know, when we talked about DNS before, when we know the IP address, we know where to send those data to, right? And as you can see, let's say network computer A will communicate to network 1, and let's say Facebook server has this IP address, right? And then it would send back to, let's say, network 2 to now be sent to IP address with 192.168.2.1, right? Let's see. So before moving to data link layer, one thing to add with the network layer is, let me go back to one slide. Let's see. This one. Yep. So if IPv4 is very limited, the question why is how come we are still using it, right? So IPv4 has only about 4 billion numbers, give or take, right? And again, with the devices, we're definitely way past over 4 billion. So how is it possible? So what it's currently doing is it's assigning unique global IPs to, let's say, an ISP or a network, right? And then in one network, it can now assign the same IPs with another household. To clarify this, let's say one household has the IP number, let's make a simple number, IP number 5, and the other household has the IP number 2, right? That let's say that those are unique. But let's say in household 1 and household 2, inside of them they have a lot of devices and they would assign IP as well. But now locally they can assign the same numbers. Let's say I have the IP 127 in house A. I also have the IP of 127 in house B, right? Meaning from the unique IP, they also have local IPs, right? If that was not clear, feel free to ping me and I can explain more. And now we move on to data link layer. Data link layer, one of the takeaway is the data is being enclosed in a frame, right? It needs a MAC address, the source and destination, right? Also needs the segment, I mean the data packet and the tail. And here's a visualization of how the data link layer would go about, right, to pass that information. And as you can see, here's the frame. The computer would pass it to the network, and usually in your organization, let's say in your company, you would have a room where the ISP is there, where they only have access, and the ISP would basically send that over, right, to, again, the internet, right? And then the other ISP from another office or the same ISP would basically receive that and pass that over to the device, right? Okay. And now we go to the physical layer, right? So from the data, from the transport layer, we call it as a segment. And when it passed down to the network layer, it will now be called packets. It just segment plus source IP and destination IP. Packets is the one that we're always familiar to reading, and then when we're using the terminal, right? Data link layer would now include the packet plus the MAC address, right? Source and destination. And now once it traversed to the physical layer, it's just gonna be ones and zeros, which we call bits as well. See, and then with bits, it's basically signals. Um, it's usually lights or electrical current bouncing around inside of the cables, right? And once it reached to the other to the receiver's physical layer, it would now go from bottom to top, right? Until it reaches the application layer for the user to see, for the other user to see. So to recap, right? Let's say you interact with your Facebook and let's say send a message to your friend. It will go to application layer down to the physical layer. Then from your friend, it would go from the physical layer to the application layer. Then your friend sees the message, right? On the right side, this is another way to just segment categorize the different OSI model. Again, OSI model should be the one that you really have a grasp on, even just memorizing them, and then you'll basically understand how each one works, the protocols. And if this gives you more clarity, the three layers are basically software layers. You don't really get to touch them, right? And the bottom three layers are the one, this is hardware, where you basically can touch them, right? Or see them, right? Okay, just a recap. Okay, more examples. These are protocols, right? So if you haven't heard IMAP, oh, that's a presentation layer protocol. Okay, physical are the fiber, coaxial cables. Another way to categorize them, it's called data, data, data. And then once it reaches transport, it becomes segment, network becomes packet, frames, and then bits. And this is another a graph to show. And that should be the end of it. Okay, if you have more questions and need more examples, feel free to ask me in MS Teams. Thank you.